And it's looking like it's going to be page 8 of your unit handout. And what we're looking at today is called an arithmetic series. And boy, the difference between that word and the word we've been using, which is sequence, is huge, but it's a subtle difference in terms of the word, right? You see sequence, series, it's all math. No, it's different. So we are going to learn what a series is. We're going to learn what an arithmetic series is. And then we will be doing some calculations with arithmetic series over today and Monday. So we're breaking this section, which is 1.2 in your textbook, into part 1 today and part 2 on Monday. So what is the definition of a series? Forget about arithmetic. A series is what you get when you add the terms together from a sequence. That's the series. So an arithmetic series is the sum of the terms of an arithmetic sequence. In a sequence, we use commas to separate things, but in a series, we use addition symbols or signs. So for example, I'll get to that in a second. And we use Sn to tell us the sum of n terms. Now I want to spend some time to talk about this. Don't confuse S sub n with T sub n. T sub n is what's the term? What's that term? What's that term? What's that term? S sub n is different. So, as an illustration, if you look at this sequence, 1, 3, 5, that's an arithmetic sequence with a common difference of 2. It doesn't take much to see that, I don't think. That this is an arithmetic sequence and it's got a common difference of 2. First term of 1. Yeah? Okay. On the other hand, 1 plus 3 plus 5 plus 7 is an arithmetic series. It has a common difference of 2 and it has a first term of 1, but because we're adding the terms together, it's what we call a series. Now, what about this S notation? I've told you we use S to denote. Check. So what does this Sn mean? A series is the sum of the terms of a sequence. Well, if I take a look at this series, focus up here, please. And I say, what is S1? Well, S1 is 3. This is a little harder for me to explain, but if I say add up the first term, you look at the number 3, you go, well, it's 3. Who can tell me what you believe S2 is? It's 10. Can you explain why? Sorry? Yeah. It's the sum of the first 2 terms. So the second term is 7, but S2, T2 is 7, S2 is 10. It's the first term plus the second term. S3 would be the sum of T1 plus T2 plus T3. And really, that's maybe worthwhile pointing out. T1 plus T2 plus T3. That's what's going on here. S4 would be T1 plus T2 plus T3 plus T4. So if you add up the first 3 terms, you get 21. I want to point something out to you here. And I think this is very important. If I said to you right now, what is S4? You don't have to add up the first 4 terms. You could say, and this is really, really important for later, that S4 is going to be S3 plus T4. Can you just let that sink in? S4, the sum of the first 4 terms, is S3, which is the sum of the first 3, plus T4, which is the 4th term. In other words, everybody, look, you already know that this is 21. So how are you going to find this total? You can go back and go 3 plus 7 plus 11 plus 15, or you could say it's 21 plus 15. Anyway, this process continues. You can continue to add terms to find the different sums. S6 is 78. S7. I mean, it gets a little tiresome after a while, doesn't it? To have to add these together. We're going to come up with formulas. So, what is S5 for this series? I would like everybody to calculate S5 for this series. And also calculate S10. I will put down what S5 is just to make sure that everybody is on the right track. But I want somebody to confirm that it is 40. It is, okay. So what I've done here is I've said, well, this is 2 plus 5 plus 8 plus 11 plus 14. I've figured out the common difference is 4 or 3 rather. It's not an onerous task. You just look at it, you go, well, I'm adding 3 each time. So then I added those numbers together, but unfortunately for you, 6, 7, 8, 9, 10. Unfortunately for you, to find S10 requires that you actually find T6, T7, T8, T9, and T10 unless you know a shortcut. Put your hand up and down if you've found it. Oh, wow. Wow. Oh, let's see. 4 plus 9 times 3 is 27. 27 and 4 is 31. 31 times 31 times 5. I want to say it's 155. I didn't do that, by the way, by adding the 10 terms together. There's something else I did. So we're adding 3 each time, 17, 20, 23, 26, 29. Those of you that have found it already to be 155, and anybody else confirm it's 155? Okay. Did you just do this and add them all up? I don't know how else you would do it. It's not like it's a big secret, but the formula hasn't been taught to you yet, and it is a formula. Quite frankly, you don't have to. If you haven't got it yet, I don't care if we spend class time doing it. I care that you understand T10 plus T9 plus T8 all the way down the line is what you would have to do to find S10. Okay. Clearly, there's got to be a shorter way to do it. So, as an example, it says here, find the sum of the first 100 terms of this sequence. And the story goes, this is apparently a true story, Leonhard Euler, last name is Euler, it's spelled this way though, famous Dutch mathematician in, I want to say the 1600s, 1700s, as a small schoolboy was in class, might have been 6 or 7, and he was a disruptive student. And the reason he was disruptive is in math class anyway, he understood math. He was brilliant. You look him up online, there's all kinds of math that we use today that we wouldn't have without him. So his math teacher gave him this problem in the hopes that it would keep him busy for half an hour or so. And Euler wrote a couple things on paper and gave him the answer right away. He knew what the answer was. And I'm going to show you his method, which is going to lead us to a formula. And I've just got lines up here to keep my work organized. What he said is that what this person is asking me to do is to find S100, which is 1, plus 2, plus 3, plus... And, you know, if he was really smart, he'd go, I don't want to write all this down. So let's just put ... Hey. Okay. He's not here today? Right here. So he writes it down a second time. When you add these two lines, you get 2 times the sum of the first 100 terms. S plus S is 2S, equals 101 plus 101 plus 101 plus dot 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 plus 101 plus 101 plus 101. So there's 100 items in this list because it was from 1 to 100. But he doesn't have to add 100 things because they're all identical. All he has to do is say that this is going to be 101 multiplied by 100 because that's how many there are. That 101 is repeated 100 times. And multiplying 101 by 100 is child's play. You just add 2 zeros. But keep in mind, this is 2 times the sum of the first 100 terms. So he has to divide that by 2. That's not too difficult. S100 will equal 10,100 divided by 2, which is going to be 5,050. And there's a lesson to be learned here. The lesson is that these two things added together are the first and the last term. And then what you do is you take the first and the last term after you've added them together, you multiply by how many terms there are, and then you divide by 2. And that's going to lead us to a formula. What's the general formula for Sn? Well, you take the first term plus, now there's something here that gets kind of sticky intellectually, plus the last term. The last term is Tn, and I want to explain why Tn is the last term. It's the last term because you're finding Sn. So think about it for a second. If I said find S8, how many terms are you adding? 8, right? What's the last term? The 8th term. So if you have S8, this would be T8. It's the last term. You need to somehow remember, though, that when you see Tn in this formula, it means the final term or the last term. Then you multiply that by the number of terms, but then you have to divide by 2. And that's how the formula is normally given. So this is a formula you can use from now on to find the sum of any number of terms in a sequence if you know the first term and the final term that you're trying to add. And you know how many terms there are. Okay. This will also be on a formula sheet. No, I think I'll get you the formula sheet today. Okay, we have one more thing to do before we get to some examples. If Sn equals n over 2 times t1 plus tn, and tn is equal to t1 plus n minus 1 times d, what this question is saying is write a second formula for Sn. We are going to put t1 plus n minus 1 times d. We're going to put this right there because that's what Tn is. We're doing a substitution, an algebraic substitution. And we get Sn equals n over 2 times T1 plus T1 plus n minus 1 times d. And I have in brackets here T1 plus T1, so we can certainly add them together to get Sn equals n over 2. And then in brackets 2T1 plus n minus 1 times d. So we have two formulas for Sn. I think this is at the top of the next page. Yes? So we're going to do some problems here right away, and it's now that we have the formulas, the rest is algebra. But I want you to note that the formula on the left and the formula on the right can only ever be used if you know how many terms you're adding. You have to know n. Okay? No doubt about it. You have to know how many terms you're adding. But the one on the left, all you need to know is the first and the last term. You don't even need to know the common difference. The one on the right, all you have to know is the first term and the common difference. You don't even need to know the last term. So depending on the type of question we're asked, we might choose one formula over another. All right, let's get to it. What's the sum S12 equal to? So let's make an itemized list of what we know. By looking at this series, because there's plus signs in there, we know the first term is 2. We know the common difference is 4. And we know n is 12 because we're trying to add 12 terms together. So the question is this: could we use this formula, Sn equals n over 2 times t1 plus tn? Well, no. Not without finding the last term first. I want you to roll that around in your head. In this formula, tn is the last term. Do we know the 12th term? No. Could you, everybody, could you find the 12th term using this? You could, and some of you may decide to do that. You could find the 12th term using this and then use this formula. But instead of doing that, we could find the sum directly using this formula. See, I'm of the opinion that although you could find the 12th term first using this formula, then use the top formula, which looks simpler than the bottom formula, I'm of the opinion that 2 formulas is more work than 1. That's just the way I think. If there's one formula that I can use to get an answer, why don't I just get the answer? So all we're going to do is put the numbers in here. S12 equals 12 over 2 times 2 times 2 plus n minus 1. Man, you guys, you know, I so want to write 11 here. Right? N minus 1. I'm going to slip into that mode sooner or later, but for now I'll just write 12 minus 1. And then times d, which is 4. And I would like everybody to calculate what this is, just to make sure you know how to use your calculator properly and what the order of operations is. My advice, by the way, would not be to enter it into your calculator all at once. I don't think that shows a real lack of understanding of math, of just plugging it all in. And I want to say it's 288, but I'll give you a minute to... Yeah. Anybody else for 288? Thomas? The problem with your calculator is after a while you get hypnotized by it and you don't even think about what you're entering. Why would you ever enter 12 divided by 2 in your calculator as part of a calculation? You should know 12 over 2 is 6. And this is 4 plus 44. 11, which is 12 minus 1, that's 11, times 4 is 44. So I don't know. I guess I don't care how you enter it in your calculator. I care that you get the right answer. But I'm left with 48 times 6, which I believe is 288. So the sum of the first 12 terms is 288. Now, if you wanted to, yes, you could find the 12th term here first, and some of you may decide to do that. Okay. S14 here. So T1 is 12. The common difference is negative 5, and we're trying to find the sum of 14 terms. Same formula, because it's the same set of information. This time I'm going to put my substitution down, but I'm not going to show any steps, and then we'll write down what the answer is. So S14 is 14 over 2 times, in brackets, 2 times T1, which is 12, plus n minus 1. Again, I just want to write 13 in there, because it's 14 minus 1, but I will write 14 minus 1. Times d, which is negative 5. Don't forget that negative. And your job is to calculate what that sum is. I want to say negative 287. I got it? So I'm just going to give everybody a minute here and make sure that you are able to calculate that. I will, I guess, show you on a calculator. I won't write down the steps on paper, but I mean, if you have to go 2 times 12, that's fine, but it's 24. I would work from the brackets out, so 24 plus 13 times negative 5. That's what we have in brackets. 14 minus 1 is 13. And then you multiply by 7, because 14 over 2 is 7. You get negative 287. Okay, let's try one more. No, do I have a C on yours? I do? It's quite, no, I meant to just go A and B. We won't do C. We don't need to do this 3 times. These, by the way, you would just rewrite as decimals. We had this discussion, I think, yesterday or the day before. I don't want us to get bogged down in fractions here. I guess we can do it. I'll just do it on our calculator. I'm going to use this formula, the bottom formula. I want to find the sum of the first 9 terms. So I'm going to have to take 9 divided by 2 and multiply by, in brackets, 2 times the first term, plus n minus 1 times the common difference. Well, n is 9. 9 minus 1 is 8. So plus 8 times the common difference of 0.5. It's 20.25. If you want to, impress your family, your pets, you can convert it to a fraction. It's 81 quarters. All right, let's take a look at number 2. What's the sum of this series? Why can we not find the sum using one of these formulas at this point in time? So everybody think about that for a minute or two. We are not able to use either of these formulas at this point in time to calculate the sum. Who can tell me why? We don't know how many terms there are. But luckily, we've learned to figure out how many terms there are, and I put a lot of thought into how I structure things. Because on our quiz, the very last question on our quiz was giving you an arithmetic sequence and saying how many terms are there. And you know how to do that. So we're going to do that same approach to find out how many terms there are. Then, once we know how many terms there are, you really could use either of these formulas, but I would prefer the top formula because it's simpler. So the first term is 5. The common difference is 10. And this is our goal. Now I want to go a little slow with this one and ask you a question so if I know the answer, I can help you more. When we put in these two things and we run them through, Tn equals T1 plus n minus 1 times d to get Tn equals 5 plus n minus 1 times 10. Clean that up a little bit. Are you with me so far? How many of you would simplify this and then put 295 in to find n? Is there anybody who would put 295 in right now? You can. You certainly can. Let me show you both methods. Tn equals 5 plus n minus 1 times 10. And this is our problem. I can put 295 in now. And when I do it this way, I'm never going to multiply this 10 through. I'm not going to need to. I'm going to subtract 5 from both sides first. When I do that, I get 290 equals n minus 1 times 10. I'm trying to get into the brackets where I have that n minus 1, so I have to peel off that 10. I'm going to divide both sides by 10 to get 29 equals n minus 1, which means you add 1 to both sides and get n equals 30. I'm not saying I want you to do it that way. I'm not saying that. I'm saying you can do it that way. There's nothing wrong with it. What I have taught you to do is the following. Multiply that 10 through, then simplify this, then put 295 in. But I don't care which of these two approaches you take. If I put 295 in now and solve, I'm going to add 5 to both sides to get 300 equals 10n, and when I divide by 10, I'll get 30. Anyway, question 5 on the quiz is important because now question 5 on the quiz becomes just one thing you have to do before you can really answer this question. Now that we know this is T30, we know that n is 30. And we can find the sum. I would just use this 30 over 2 times 5 plus 295. It's a lot quicker too. As well as being a simpler formula, it makes things quicker. Say 4,500. I better double check that 315. I think it's going to be 4,500. So S equals 4,500. Try one more. Just want to see where we're at here. Yeah. Let's not do C. We don't need to. The first thing that you need to do here, since you know that T1 is 6 and D equals -5, is you need to find the number of terms if you want to add them up. So again, putting things into the general term formula will give Tn equals T1 plus n minus 1 times -5, and we need to know n when Tn is -229. Which means you need to solve this equation. Well, maybe, you know what? I'll ask the question. How many of you now would put it in now? It's easier, isn't it? I think it's quicker. If you want to expand that out and then put it in, that's fine. But I'm just going to write this down. -229 equals 6 plus n minus 1 times -5. And I'll give you a minute to solve that equation for n. By the way, if you rearrange it from here, you would subtract 6 from both sides, then divide both sides by -5, then add 1. Is it 48? It is 48. So you should get n equals 48. Then it's a matter of saying, again, it's just my preference. I really like this formula better. This one here. This one. Ooh. Oh, I don't know why I was doing that. That's the formula I like. So S48 will be 48 over 2 times 6 plus -229. I have to say, I'm not even going to try that in my head. Oh, excuse me. -5352. Is that right? So really two very kind of basic types of questions you need to know how to do. The questions in 1 and 2. We're not going to do C, but let's do the word problem here. We've got a mathematical firefly that's flashing twice in the first minute, 4 times in the second minute, 6 times in the third minute. Well, this is an arithmetic pattern. What this is saying is n and Tn represent the minutes and the number of flashes. So in the first minute, this little guy blinks twice. In the second, blinks 4 times. In the third, 6 times, etc. What we have is an arithmetic pattern. You'll notice I say arithmetic pattern because we can think of it as an arithmetic sequence or we can think of it as an arithmetic series. It doesn't matter. It's an arithmetic pattern where T1 is 1 and D is 2. We're adding 2 each time. Oh, excuse me, man, oh man. how many flashes will there be in the 30th minute? Look very carefully at what this says. In the 30th minute. Which means, what is T30? That's what this question is asking. I think this is a case, everybody, where since we just want to know what T30 is, we can use this formula, but we don't have to develop it and simplify it. We can just go T30 equals T1 plus 30 minus 1 times D. It's probably the simplest thing to do. So T1 is 1 plus 30 minus 1 times D, which is 2. That's a pretty easy calculation to figure out. 2 is 58. I want to say 50. That can't be 59. 29 times 2. I've written something down wrong, so who can tell me what's wrong? Right. I wrote a 1 here. The reason why I knew I wrote something down wrong, that should be 2, is when I calculated my answer, I got an odd number. And all of the terms are even. So I knew I did something wrong. 50, I'm getting 60 there. You probably could have figured that out anyway without using a formula. Because these numbers are all twice as big as these numbers. Anyway, in the 30th minute, this little guy flashes 60 times. 60 flashes. Part B says, and I'm actually going to rephrase this. What if I said, how many flashes in 30 minutes? And I am going to change that for next time in my note package. I'm not saying here how many flashes in the 30th minute. I'm saying how many flashes in 30 minutes. And that means we have to add up all the flashes in the first minute plus all the flashes in the second plus et cetera, et cetera, et cetera. A was asking us to find T30. B is asking us to find S30. So we could use either formula because we actually know T30, don't we? We've calculated it already. So we know T1 is 2. We know T30 is 60. We know N is 30. So I can take N over 2 times the first term plus the last term. And you can do this on your own. If you wanted to, you could try using the second formula. You're going to get the exact same answer we get here. I want to say 930. This is going to work out to 930 blinks or flashes in a total of 30 minutes. Any questions with B? I think there was a C. What does this mean? So first of all, I want you to understand something. I'm not giving you this question because this is a Math 20-1 question, or I would give it to you on an exam. I'm giving it to you because many of you will end up taking calculus eventually. Many of you will become better and better and better at math. And this is more of an abstract question, but I think it's a valid question for this course and our discussion, even though it might not be on an exam. How many flashes in n minutes? And it's a total. Well, Sn is n over 2 times 2t1 plus n minus 1 times d. Right? That's the formula. Well, let's put in everything that we know. Sn is n over 2 times 2 times 2 plus n minus 1 times 2. So what I've done is I've put in T1 and I've put in D. Let's simplify that. Okay. So if I simplify this, what's going on here? If I simplify this, I have n over 2, and inside I have 4 plus 2n minus 2. I've expanded this by multiplying that 2 through. I can simplify it more. And write 2 plus 2n. I can multiply this n over 2 in and get n over 2 times 2 plus n over 2 times 2n. And we get some canceling action happening. The answer to the question is Sn equals n plus n squared. That's interesting. What was question B asking us to find? The total number of flashes in how many minutes? 30? Go ahead and take 30 plus 30 squared. Get 930. Wasn't that the answer? So what we've done is we've come up with a general formula for the sum, which means if I said to you, okay, well, how many flashes are there in an hour? Well, you'd take 60 plus 60 squared. How many flashes in 3 minutes? You'd take 3 plus 3 squared. Anyway, I wouldn't worry too much about this. This is another case of us trying to flex our mathematical muscles and get better and better at this. All right. So on page 27, questions 1 to 3 and number 9 are practice problems. Sorry if I seem a little down. I guess I'm just tired today.